Hello everyone. In the previous video, we have understand how to solve the homogeneous differential equations. In this video, we will understand how to solve the equations which are not in homogeneous type but can be converted into homogeneous differential equations. Let us suppose we are given to solve the equation in the form of dy by dx is equals to ax plus by plus c whole divided by a dash into x plus b dash into y plus c, where a divided by a dash is not equals to b divided by b dash. In this case, we put x as x dash plus h and y as y dash plus k, where h and k are my constants, and when we will use this substitution, we will have the value of dx as dx dash and dy as dy dash. Therefore, this equation number 1 will become dy dash upon dx dash is equals to a times x dash plus h plus b times y dash plus k plus c whole divided by a dash into x dash plus h plus b dash into y dash plus k plus c dash. And when we will simplify this term, this will be like a into x dash plus b into y dash. Rest all the terms are constants and we can combine them as a into h plus b into k plus c whole divided by a dash into x dash plus b dash into y dash plus a dash into h plus b dash into k plus c dash. And then we will put these two equations equals to 0. From this pair of equations, we will find the value of h and k, that is a into h plus b into k plus c equals to 0, a dash into h plus b dash into k plus c dash again equals to 0. Solving this equation, we can write it as h upon b into c dash minus b dash into c is equals to k upon c into a dash minus c into c dash into a is equals to 1 upon a b dash minus a dash into b. And from here we can find the value of h as b into c dash minus b dash into c whole divided by a b dash minus a dash into b, and the value of k will be c into a dash minus c dash into a whole divided by a into b dash minus a dash into b. And we know that the given condition is that a upon a dash is not equals to b upon b dash. It means that a into b dash minus a dash into b is never going to be 0. Therefore, the value of h and k will be a finite number. After taking these two equations equals to 0, then equation number 2 will reduce to homogeneous equation in x dash and y dash, and then we can solve this in our usual process. This was the case number 1. In case number 1, what we have is that a upon a dash is not equals to b upon b dash. What if they are equal? That is case number 2. In that, we have to solve the equation dy by dx is equals to ax plus by plus c whole divided by a dash into x plus b dash into y plus c dash, when a upon a dash is equals to b upon b dash. In this case, we will let that a upon a dash is equals to b upon b dash is equals to 1 upon m. Then this equation number 1 implies the value of a dash can be equated as a into m, and the value of b dash can be b into m. Now the equation number 1 will become as dy by dx is equals to ax plus by plus c whole divided by m into ax plus by plus c dash. And now we will put ax plus by equals to t, so that a plus b into dy by dx is equals to dt by dx, which will help us to create this form into variable separable form. Let us try to understand this topic with the help of some examples. The question number 1 says to solve the given differential equation, and we can rewrite this given differential equation in the form of dy by dx is equals to 7x minus 3y minus 7 divided by 3 into x minus 7y minus 3. Let us mark this as equation number 1, and comparing this equation number 1 with dy by dx is equals to a into x plus by plus c whole divided by a dash into x plus b dash into y plus c dash. From here, the value of a upon a dash is equals to minus 7 by 3, and the value of b upon b dash is equals to minus 3 by 7. Clearly, they both are not same. So we will start putting x as x dash plus h and y as y dash plus k, where h and k are constants. Therefore, the value of dx will be dx dash, and the value of dy will be dy dash. The equation number 1 will become dy dash upon dx dash is equals to minus 7 into, please make a correction that we have a minus common here, and this is the same minus sign we have skipped before. 7 into x dash plus h minus 3 into y dash plus k minus 7 whole divided by 3 into x dash plus h minus 7 into y dash plus k minus 3, and this can be simplified as minus common 7 into x dash minus 3 into y dash plus 7h minus 3k minus 7 whole divided by 3x dash minus 7y dash plus 3h minus 7k minus 3. The next thing we have to do is we have to equate these two equations equals to 0 and find the value of h and k from here. 7h minus 3k minus 7 is equals to 0. 3h minus 7k minus 3 equals to 0. You can use any method to find the value of h and k from these two equations. You can either use elimination and substitution method, or you can just directly use the formula we have shared before. According to that formula, it will be h upon 9 minus 49 is equals to k upon minus 21 plus 21 is equals to 1 upon minus 49 plus 9. From here we can say the value of h will be 1 and k will be 0. Let us mark this as equation number 2. After that, the equation number 2 will become dy dash upon dx dash is equals to minus of 7x dash minus 3y dash whole divided by 3x dash minus 7y dash. Now this is our homogeneous differential equation, and in homogeneous differential equation we put y dash as v into x dash, which helps us to find the value of dy dash upon dx dash as v plus x into dv by dx dash. Here is x dash also. So the equation number 3 will become v plus x dash into dv by dx dash is equals to minus of 7x dash minus 3v into x dash whole divided by 3x dash minus 7v x dash. After simplifying, this will be v plus x dash into dv by dx dash is equals to minus of 7 minus 3v whole divided by 3 minus 7v. Taking v on the another side, taking LCM and simplifying, this equation will change into x dash into dv by dx dash is equals to 7 into v square minus 1 whole divided by 3 minus 7v. This is clearly in the form of variable separable. Then separating the variables, this will become 3 minus 7v whole divided by 7 into v square minus 1 into dv is equals to dx dash upon x dash. Integrating both sides, this will become 1 by 7 integration of 3 minus 7v whole divided by v minus 1 into v plus 1 dv is equals to dx dash upon x dash. We have to apply partial fractions on the left hand side, and this will change into integration of minus 2 divided by v minus 1 plus minus 5 upon v plus 1 into dv, and we have taken 7 on the right hand side. After integrating, this will become as, the simplified version of this equation can be written as log of c is equals to 2 times log of v minus 1 plus 5 times log of v plus 1 plus 7 into log of x dash. That is also equals to log of c is equals to log of v minus 1 whole square into v plus 1 to the power 5 into x dash to the power 7. That is, c is equals to v minus 1 square v plus 1 to the power 5 x dash to the power 7. Back substituting the value of v as y dash upon x dash, this will become as c is equals to y dash upon x dash minus 1 to the power 2 y dash upon x dash plus 1 to the power 5 into x dash to the power 7. Taking LCM, y dash minus x dash to the power 2 divided by x dash square into y dash plus x dash to the power 5 whole divided by x dash to the power 5 into x dash to the power 7, and this will got cancelled out. The simplified version be c is equals to y dash minus x dash whole square into y dash plus x dash to the power 5. Since we have used the value of y as y dash plus k and the value of x as x dash plus h, and then we have evaluated the value of h as 1 and k as 0. Therefore, the value of x will be x dash plus 1 and the value of y will be y dash plus 0. From here, we can find the value of x dash as x minus 1 and the value of y dash will be y. Using these two values, the final equation will become as c is equals to y minus x plus 1 whole square into y plus x minus 1 to the power 5, which will be the required solution of the given problem. Let us try to do one more question. The given differential equation is dy by dx is equals to x plus y plus 4 upon x plus y minus 6. Comparing the given differential equation with dy by dx is equals to ax plus by plus c whole divided by a dash x plus b dash y plus c dash, and we get that a upon a dash is equals to b upon b dash, which is equals to 1, and from here we can see the value of m is 1. Therefore implies the value of a dash is equals to a and the value of b dash is equals to b again, and we can rewrite the given differential equation as x plus y plus 4 whole divided by m into x plus y minus 6. Here the value of m is 1, so we can see the differential equation is again the same. And the general rule says that we have to put ax plus by is equals to t, and the value of a and b are 1 again, implies we will use x plus y is equals to t. Differentiating it, we can get the value of dy by dx is equals to dt by dx minus 1, and therefore this equation number 1 will convert into dt by dx minus 1 is equals to t plus 4 divided by t minus 6. Taking minus 1 on right hand side, and simplifying it, it will convert it into 2t minus 2 divided by t minus 6, that is dt by dx is equals to 2t minus 2 whole divided by t minus 6. This is clearly in the variable separable form, and we can write it as t minus 6 divided by 2 into t minus 1 dt is equals to dx. Integrating it both sides, the left hand side can be simplified into 1 minus 5 upon t minus 1 into dt. I have done this by simply adding and subtracting 1 here, and the right hand side will be same. After integrating, the value will be half into t minus 5 into log of t minus 1 is equals to x plus c. Back substituting the value of t here, this will become half of x plus y minus 5 of 5 into log of x plus y minus 1 is equals to x plus c, which is the required solution of the given problem. I hope you have made an understanding of this topic, that how you have to solve this kind of questions. To build a little more confidence in this topic, you can try these questions. If you have any doubts, then please let me know in the comment section. And if you have found this video useful, don't forget to share it with your friends. Happy learning!